I want to use this module to address an issue in elementary math education around the idea of problem solving. And the issue is that it has become pretty conventional in our classrooms for teachers to teach students to look for what's called key words. Look for the key words. Now, you have probably been in classrooms either as a child or maybe in your service learning. And in these classrooms, maybe you've seen posters like this. So teachers teach students in a story problem and a word problem to look for the keywords. If you see some or increased by or in all, you should add. If you see words like takeaway, leftover, or just left, you should subtract. And if you see words like product twice, multiply, rows of, you should multiply. Or if you see quotient, equal groups, divide, distribute, you should divide, of course. Well, these keyword idea often leads to problems, and it actually detracts from true problem solving. I'm going to use this video to try to convince you that this is a bad idea and we should come up with a better idea for teaching problem solving. Why do keywords not work? Here's an example. Avocados come 4 to a bag. Tommy buys 3 bags. How many avocados does he have in all? Now, what students will do with teaching the keyword idea, they'll go, oh, in all is a key word. And sometimes teachers teach students to underline and circle the numbers, or underline keywords and circle the numbers. So they'll circle the numbers, they'll underline the keyword in all, and they'll look at the chart, and in all means to add, and students will say 4 plus 3 equals 7 and think that they're problem solving. They're not really problem solving at all, because problem solving means that we should be thinking about the context and making sense of what's happening, and not just kind of going rote on seeing things like keywords and adding in this case. So let's not do that. Instead, avocados come 4 to a bag. Tommy buys 3 bags. So pretend there's a bag of avocados. There's a bag of avocados. There's a bag of avocados. There's 3 bags. There's 4 avocados in a bag. Bear with me. So students are thinking about the context. They're representing what they're seeing in words with maybe a diagram, a picture of some sort. And now they can look to see, hey, look, I've got 4, I've got 4, I've got 4, I've got 4 3 times, or I've got 3 copies of 4. There's 12 avocados. What happens here is multiplication, not addition. All right, here's another example. Max gave away 8 baseball cards on Monday. He gave away 6 baseball cards on Tuesday. How many baseball cards did he give away? Oh, give away, give away, give away. Circle the numbers. Give away means subtract. So I'm going to subtract 6. Oh, you can't subtract 6 minus 8, but you can subtract 8 minus 6 and get 2. I'm going to say the answer is 2. That's the problem, is keywords don't always communicate the true context. And in this case, we have to think about what's happening here. So get rid of that. So Max gave away some baseball cards. I'm going to do this fast. He gave away 8. So 1, 2, 3, 4, 5, 6, 7, 8. He gave away 8 baseball cards on Monday. And then on Tuesday, he gave away 6 baseball cards. So I'm just kind of thinking, letting students follow their noses and think about the situation. So he gave away some baseball cards. He gave away some baseball cards. How many baseball cards did he give away? Well, he gave away 8 and he gave away 6, and that would be a total of, he gave away 14 baseball cards. And I'm going to argue that if you do not teach students the whole keyword thing, they won't make this mistake. They'll just think. Teach students to think. Teach students to draw pictures. Teach students to follow their noses and see what's happening. I will argue that without the keyword situation, more students will think and get the correct answer. I just have 2 more. Molly and Robbie have $17 altogether. Molly has $9. How much money does Robbie have? Well, again, here's the problem. Circle the numbers. Underline the key word back on that chart. Altogether means add. And so students don't even think. That's the problem. It's really not problem solving. It's just mimicking something that they were told, that you should circle the numbers and underline the key word. And it's maybe they would, how much altogether, keyword, that's an add keyword, and so they're going to say $26. Now you might say, but that doesn't make sense. I know. That's the point, is we teach students to do these things that don't make sense. Now, what would it look like in terms of problem solving? Molly and Robbie together have $17. So here's Molly, here's Robbie, and together they have $17. Molly has 9. Oh, Molly has 9 of the dollars. So if together they have 17 and Molly's got 9 of them, well, how much money does that leave here for Robbie? And now you can better see that this is actually a subtraction problem. The remaining $8 is what Robbie would have in order for them to have a total of 17 altogether. See, it's not the key word, it's the thinking, it's the context, it's the representation that does it. I have one more. Billy is sorting 30 Hot Wheel cars by color. 16 of the cars are blue. What is the number of cars that are not blue? So sometimes in terms of keywords and numbers, so we might write out a number sometimes, and we teach us, watch out for that. Make sure you circle the word numbers as well. So there's a 30 and there's a 16, and then here's another one that we often teach that is, I think, is a bad idea. They'll say, of means multiply. Anytime you see of, that means to multiply. So 16 of the cars. Oh, there were 30 cars. So 16 of means multiply the cars. 16 times 30 is, I think, 480. That might be what a student does. And we also might tell them is means equals. Is means equals. That's just what is. So sometimes they'll say the number of cars that are not blue equals the 16 times 30. I don't know. It's just all this messy stuff where we ignore the context, we ignore the thinking, we ignore the making sense of the problem and persevere in solving it. Remember chapter 1 and Beyond Answers? Instead, don't teach all that keyword stuff. Just make sense. Billy is sorting 30 Hot Wheels cars. I'm not going to draw them out. I'll pretend I put 30. I got 30 Hot Wheels cars. And 16, of these cars, 16 of them are blue. What are not blue then? I'm just thinking about it. I'm drawing it, and I can see that 30 cars altogether, 16 of them are blue. So the remaining 14 would not. It's actually a subtraction problem, not a multiplication problem. Now, you might argue, nah, kids don't make those mistakes. They think about the thing. Well, there's been a couple of recently in the last, I don't know, 5 or 10 years. This one is by Robert Kaplinski. I didn't put his name on here. You might Google him. Robert Kaplinski. And he did this little study. He gave 32 eighth graders this problem. There are 125 sheep and 5 dogs in a flock. How old is the shepherd? And he wanted to see if students would figure out what makes sense and what doesn't make sense. So back to the point here, when students follow key words and do things that don't make sense, you might say, well, they wouldn't do that. Kids, they're going to realize that. Well, let's see. 32 eighth graders, 125 sheep, 5 dogs. How old is the shepherd? How many of the students actually answered the question? And how many of the students make sense of the problem and say, well, you can't figure out the age of the shepherd by knowing how many sheep and how many dogs there are? What do you think? Take a minute and just guess. Of the 32 eighth graders, how many said, nah, this doesn't make any sense? And how many of them maybe even looked for a key word and did something? All right? All right, make your guess, and then I will show you the video.
There are 125 sheep and 5 dogs in the flock. How old is the shepherd?
What? There are 125 sheep and 5 dogs in the flock. How old is the shepherd? I don't know how to solve this.
Why is that?
Because it doesn't talk about anything about the shepherd. Like, it doesn't say how old, like how long he's had them or anything. So it doesn't give me any hints about anything.
We got one.
Okay. Thank you very much. There are 125 sheep and 5 dogs in a flock. How old is the shepherd?
$120 old.
How do you know it's 120? Can you please write down? Now, how do you know that the shepherd is 120 years old?
I'm going to subtract 125 minus the 5 dogs and a flock.
So, you're going to start to see more of this, but here's a pretty common thing. Students look at a situation, it may not have been the key word issue here, but you have a relatively large number and a relatively small number. And the expectation is, and students' thinking is, you have to do some math. And maybe that's part of the problem here is maybe you might argue, and I would understand, that this is a setup. Students are often given problems and expected to do something to solve them. And to give a problem that is nonsense is not part of their experience. But maybe we should help students to learn how to make sense and not just always do things. But anyway, back to my story. You have a big number and a small number, 125 and 5, and students will just often subtract because multiplication, that would be weird. Take a big number and multiply it by another number would give a bigger number. So multiplication doesn't make sense. Addition, same kind of a thing, but subtraction, a big number and a small number, I'll subtract. Or maybe divide. Watch this.
Okay. Thank you very much.
Divide, 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 subtract, divide, subtract. Oh, there's an ad. One ad. I don't know what that one was. Subtract, divide, divide, divide. Add again. There's 2 ads. I don't know, 50. Divide, divide, divide. 42. Divide, divide. I don't know what's going on there. Another divide. Another divide.
Thank you. Can you tell me, how did he know to divide?
Because it doesn't say the difference, or it doesn't say the sum, or the product, or something.
I see.
See it? Doesn't say. I'm looking for keywords. I didn't see sum or product or difference. I didn't see the keywords I'd expect, so I'll go with divide. And 125 divided by 5 works out evenly, so it just is kind of a setup in a way that division might be what a kid would naturally do, even though the problem makes no sense.
Okay. Thank you very much.
Standards for Mathematical Practice 1. You read about it in Chapter 1 of Beyond Answers. We want students to look at problems and explain the meaning, plan a solution, ask, does this make sense? And so we are seeing evidence of this not happening. I'm going to give you some resources in the slide, in the Google slide deck. You can actually link to these, but Graham Fletcher, G. Fletchy, has a little article, a blog about teaching key words. She says, forget about it. There's a nice article, actually, I think it's a book now called Nix the Tricks, teaching kids the tricks of mathematics instead of the thinking and the reasoning. And then this one takes this same idea of the flock and the dogs and the shepherd, and this teacher kind of redid it to work with her first and second graders. The idea being, maybe my first and second graders haven't yet been tainted by the key word thing. So this teacher rewrote it to be friendly at a first and second grade level, and you can read about it if you follow that link, but very, very similar results, unfortunately. All right, now we're going to move into some work in this module, and I want you to understand why I am not going to address keywords and tricks, but we're going to get at the mathematical thinking behind things. Check it out.